Hello and welcome to the second part of the MD100P test and calibration video. In this video we will connect our test equipment and calibrate the MD100P. So let's get started. First we will remove the center point jumper on the MA circuit and connect our bleeder resistor. This bleeder is made up of 10 each 100 ohm 2% tolerance metal film resistors. All the resistors are connected in parallel, which gives us a total resistance of 10 ohms. For smoothing, I've added a 47 microfarad 16 volt capacitor. The last component is a bridge rectifier, which consists out of 4 high-speed diodes. Once I connect my oscilloscope to this, I will have a 10:1 ratio, which means at 1 MA actual current in the unit, I will get a reading of 10 millivolt on my oscilloscope. Since this is a 10 MA, 20 MA and 30 MA unit, I want to see readings of 100 millivolt RMS, 200 millivolt RMS and 300 millivolt RMS on my oscilloscope. First, I will select 10 MA on the unit and a kV of around 70 kV, about center scale. Then I'll take an exposure, verify the indication on the oscilloscope, and then start adjusting the variable resistors. This unit does not have a potentiometer. It's got a linear resistor with some rings that you can loosen to adjust. There is a dedicated ring for each station one can select. So for 10 MA there is one ring, for 20 MA a different ring, and for 30 MA a different ring. With 10 MA and 70 kV selected, I will press and expose using the hand switch. After this I will verify the reading on my oscilloscope and then adjust the slider till the reading on the oscilloscope agrees with the 10 MA setting. Once finished, I will select 20 MA and then 30 MA. Now that all the MA stations have been adjusted, I will start adjusting the kV. This is really simple. When adjusting the MA, all we had to do was to put the lead shield over the X-ray source to protect ourselves. In this case, we need to expose onto the kV meter, which means we'll have to remove the lead and open the collimator. In our laboratory, we have a mobile lead shield that we use to protect ourselves, so we're not too worried about this. To adjust the kV, we will select the 10 MA station and then adjust the kV on the meter to read around 70 kV. After this, we will take an X-ray and compare the actual value measured with the kV meter with it on the display. We will now adjust the kV resistor until the reading on the X-ray machine is the same as the reading we received on the kV meter. Once finished with 10 MA, we will do the same for 20 MA as well as for 30 MA. And here you can see the end result. We selected 30 MA and around 81 kV. Our actual MA was 29.9 MA according to the oscilloscope, and our kV output was 81.5 kV according to the kV meter, which is awesome as we had around 81 kV set on the unit. The last thing we had to do after cleaning and assembling the unit was to adjust the X-ray to light field. In order to do this, we position a fluorescent screen in front of the unit with a square drawn on it. We will then switch the light on and align it with the square. After this, we turn the room lights off and make an X-ray. When the fluorescent screen is exposed to X-ray, it will light up. The adjustment will be a success if the X-ray beam lights up in the same place as where the light beam was shining. Our tolerance on this test is around 10% of the distance between the X-ray source and the fluorescent screen. In this case, the distance was 1 meter, which means we've got about 1 centimeter tolerance. As you can see in this video, we were very close, so we did not need to do any adjustments and the unit passed easily. All that remained now was to clean the unit and deliver it to the new owner. And that's another job well done. I hope you enjoyed this video, and until the next time, take care and bye bye.